Hi there everyone, today we are looking at error intervals. Alright, so this has very kind of tight ties with upper and lower bounds. Alright, so we're going to talk to you through about what that actually means, but ultimately it's about putting effectively an upper and lower bound using inequalities to contain all the values which round to a specific number. Alright, we'll talk about that in a second. So to use upper and lower bounds for the numbers in the inequality, we're probably best doing an example. All right, so if I say to you 24 to the nearest integer, or write down the error interval, what we're saying is it can be slightly less than 24, it can slightly more than 24, but because we've said to the nearest integer, I want to know what numbers either side. All right, so this is where we look at upper and lower bounds. So what I'm looking at is what number is the lowest number that would round to 24. All right, so 23.5. So what tends to be is this number drops by 1 and you tag a 5 onto it. So 23.5, that's the lower one. And the upper bound, well, you tend to just add a 0.5 on the end of it, or the next to 5, depending if it's a decimal place or not. So this would be another 5. So it would be 23.5 and 24.5. Now, in terms of the error interval, and I know many people will argue, and they always do, that this 24.5 rounds up to 25. All right, and they're absolutely right, it does. So when we're writing our error interval, the inequality is absolutely critical in terms of how you write it. Okay, so we're going to put the value of x, is what we're after, because it's 24, in between 23.5 and 24.5. And I want you to pay particular attention to these two inequalities, all right? Because it can equal 23.5 because that rounds up, but it cannot equal 24.5. It has to be less than 24.5. Hence, there's no line underneath here. All right, so whilst we're using these two values as limits, when we're looking at error interval, these inequalities are absolutely vital. And if you put a little line under this, then of course you're wrong. You're absolutely wrong. And some people will mention it, oh, it can't be that. You're right, it can't. It's got to be underneath. So therefore use it inequalities to say it's got to be less than that specific number. It can't equal it. Okay, so we use these as guides, but in terms of how we write it, we say it must be less than that. Okay. And that's hence that message there. So 8.74 to 2 decimal places, write down the error interval. All right, so what I suggested from the lower bound is you just drop it by 1 and then add a 5. So there you go, drop it by 1 and add a 5. And then for the upper bound, you just tag an extra 5 onto the end of it. So there you go. So 8.745, and then we write it. We'll hopefully have harped on about this enough to recognize I'm going to put those two numbers either side, and then my inequality doesn't have a line under it for that one, but does for that one. Okay, so that is error intervals. Okay, well, truncating kind of builds on the top of that. So truncating is a number you want to you get rid of from the unwanted digits. All right, so you don't round the number up. All right, so if I should truncate 46.782 to the nearest integer, okay, well, to the nearest integer, what would that be? All right, hopefully tell me it's going to be 47. All right, but not in this case. All right, because it ultimately you truncate it, you're going to take, basically, you don't round the number up. All right, because it even says here, look, truncate a number, you get rid of all unwanted digits, and you do not round the number up. So it's literally 46, which sounds very weird, isn't it? All right, very strange kind of concept. All right, so truncate to the 2 decimal places. So you're just literally going to cut off the 364, and it's just going to be 9.54. Really weird. All right, I'm sure you don't like it, but ultimately that's what you do when you're truncating. Okay, so it's 3 significant figures. All right, so 1, 2, 3. All right, so it's going to be 784. Those two need to be zeros though, obviously because they need to retain size, because it's 78,000, isn't it? So it needs to be 78,400. All right, because obviously that needs to retain its absolute size. All right, so that is truncating. All right, don't see it an awful lot, but here we go. So error intervals by truncating. So error interval is an inequality which contains all the values which round to a specific number. To use upper and lower bounds for the number of the inequality. So 24 truncated to the nearest integer, write down the error interval. Okay, so the lower bound is going to be 24. All right, because remember you never round up or down. All right, so it's going to be 24. And then, of course, well, how high can it go to? All right, well, if I just ignore anything which is after the decimal point, which is essentially what I'm doing, then it can go right up to 24.9999999 essentially, because we are talking bounds, we take 25. And remember, use the error interval bit to kind of support us with the inequality. All right, so anything equal to 24 or above, but not 25, but less than 25. All right, so when something's been truncated, we're literally just knocking off all the decimal points. Okay, so it mentioned that again. So 8.74 truncated to 2 decimal places. Well, it's going to be 8.74 exactly. And then the number above it will be 8.75, wouldn't it? All right, because anything basically 4999, so on, so on, and so on, and so on, and you're going to end up with this. All right, so error intervals with truncating. So truncating is a little bit weird in terms of what you do, but of course it's a word that you need to be familiar with, because if you said something's been truncated, that is what's happened to it. All right, now I don't know how familiar you are with that particular content. It's relatively new, so please do visit obviously maths-school.co.uk and get some practice on that particular thing. Thanks for listening.